It is our final chapter. Conic Sections is the name. Conic Sections, that seems like an interesting title. We get the word conic from cone, and a section we mean like a cross section, like you're taking a slice and then looking at the face. So these are the cross sections of cones. Seems kind of a random thing to study. Turns out these are very, 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 very practical, have a lot of applications. We're really not going to see the applications in this course. We save that for later math classes. If you happen to take them, you'll definitely see conic sections again. I'm actually talking about conic sections in one of my other classes right now as well. So we're going to introduce these. What are the conic sections for one? So you could say there are four different ways to take a cross section of a cone. There are four conic sections. So we'll go through them. I've got the first two. Even before we get to the first section, let's just talk about what these are. So the first two probably look familiar, right? So, imagine a cone and then think of taking, a very sharp sword and just, slicing right through it, just like a big chop. And you cut off, that corner, and that wedge just falls away. And then you look at the cross section of what is left. And so, if you started cutting here, then it would slice down at this, it's curving downwards to each side as it gets towards the base. And if you were to look at that, straight on, face it towards you, that would be a parabola. Now, we imagine that it continues infinitely far in both directions. If this cone was infinitely long, let's say. But the point is, the first conic section is that parabola. We're going to study the parabola again, going a little bit deeper this time. Okay, the next one is the circle. Okay, so instead of slicing, off one of the corners, cut the top off. So just straight across the top, nice and level and even. Cut straight, nice line there. Look at it. Well, what would you see? It would be a circle, right? If you were to point it toward yourself. So we're going to study the circle. We're going to get the equation of the circle and look at different things like that. What's next? The other two conic sections may or may not be things you've heard of before. So let me just show you all this. So the first is called the ellipse, or the third conic section, I should say. So an ellipse is like an elongated circle. How does that happen? Well, instead of cutting straight across nice and level, come up at an angle or down, or however you want to think of it. So if you make this angular cut, it's going to be circular, but it's going to be elongated. Just the nature of the way that angle hits the cone. So I don't know how good of a job I did down here, but it's kind of elongated there. Turns out the circle is actually a special case of the ellipse, although a lot of times, right, the circle is when, we just cut it straight. The ellipse has a bit of an angle. We can think of them as separate conic sections, though, and we will in this course. Okay, the last one, it's called the hyperbola. And so it looks like two parabolas back to back with this gap in the middle. How does that happen? So kind of like in the parabola we come down at an angle and just cut off, kind of that corner. In the hyperbola, we need to imagine two cones back to back. And we're going to cut so that it actually passes through both. So the parabola comes down and misses the top one, just hits the bottom one. But if we increase the angle of our cut and we come and we get both of those cones, then we'll have a parabola here, a parabola there, and this gap in the middle. And that's what it would look like if you were to, look at it face on to see the cross section. Okay, so we've got four conic sections. We got four sections. We will work with them one at a time. Well, let's dive in to 11.1. Turns out we begin with the circle. We'll look at the parabola in 11.2. It's the way this book orders it. Okay, 11.1, circles. Here's a drawing of a circle. And there are two important features of a circle. Okay, well, there's the radius of the circle. We're probably most familiar with that. There's also the center of the circle. We're going to think of the circle as being on top of an XY plane. So we'll have an XY coordinate for the center so we can graph these as well. Okay, but the point being, there's two important features. There's the center and there's the radius. If you know those two things, that's all you need to draw your circle. Okay, before we get into the examples involving circles, there are two formulas that we need so that we can work with those examples once we get there. The first one is the distance formula. And so I'm just going to show you all my work here for the distance formula and talk you through it a little bit at a time. Oh, there we go. So if you need to kind of stop here, write all this down, pause the video, and then pick it up and I'll explain each piece. That may be helpful. Of course, if we were in class, you know, we'd be putting this together slowly. Well, let's see, what am I doing? So I'm saying we want to know a formula for the distance between 2 points. So say this is my first point. I'm going to call it x1, y1. And this is my second point. I'm going to call it x2, y2. So if I draw the line between them, I want to know how far is that? What is that length, d, for the distance? And then you see all this other stuff drawn around. So it turns out we're going to take advantage of the Pythagorean theorem for a right triangle, a squared plus b squared equals c squared, right? ABC. So you notice, hey, if I'm connecting 2 points at, you know, and it goes up at this angle, that could be like the hypotenuse of a right triangle. What if I was to draw the rest of it? So I've got this dashed line and then up, creating the right triangle. If I could find formulas for these distances, then I can use a squared plus b squared equals, well, in this case, d squared. And then here I filled in what they are. Let's look at the horizontal distance between the 2 points, just going straight across this way. If I know the ordered pair here, and I know the ordered pair here, it wouldn't be too difficult to find the horizontal distance between the points. I could take this x-coordinate and subtract this x-coordinate. That's how far apart they would be horizontally. And so you see I've labeled this length as x2 minus x1. Tell me that x-coordinate, I'll just subtract that x-coordinate. That tells me the distance between the x-coordinates, the horizontal distance between them. Very similar for the vertical distance between them. That's the difference in the y values. If I know this y value, I can subtract this y value. That tells me the distance vertically between the points. Okay, now I can describe that. I can describe that. So I'm going to say, and I've kind of switched up the order. I put the hypotenuse first. D squared equals x2 minus x1 quantity squared plus y2 minus y1 quantity squared, which is what fits the Pythagorean theorem, right? A squared plus b squared equals c squared. A squared plus b squared, c squared. But I don't want d, or excuse me, I don't want d squared. I want d. Well, then what can I do to both sides? If that's being squared, I should square root. So I'm going to put a big square root over this entire right side, like so. So there's your distance formula. D equals big square root x2 minus x1 quantity squared plus y2 minus y1 quantity squared. All right, we're going to do an example in a moment. The second formula we need before we get to anything involving a circle is this, the midpoint formula. Again, imagine 2 points, x1, y1, x2, y2. So I've got my points there. I want to know the ordered pair, which would describe the point right in between Where is that location right in between? Well, you see the formula for it here. Turns out if I want the point directly between x1, y1 and x2, y2, I can do this. x1 plus x2 divided by 2, that would be the x-coordinate of that point. And similar for the y1 plus y2 divided by 2, that would be the y-coordinate for that point. Why is it that we should do this? Why should we add them together and divide by 2? Think of it like an average. I'm adding them together and dividing it in half. I'm taking the average of the x values. Well, the x values go horizontally, so the average is right in the middle, and then the average y values, the average vertically. I'm finding the average x, comma, the average y. That would be the ordered pair for the point right in the middle. It's like the average point. Okay. Finally, we get to our first example. I notice I just need to make one little adjustment here. I have something written there that I don't want you to see just yet. Okay. Here we go. Find the distance between and the midpoint. Let's practice these two formulas. We're given 2 points, -1, 3, and 5, -4. Let's start with the distance between these 2 points. Well, I'm going to think of this as x1, y1. Think of this as x2, y2. And I'm just going to follow the formula for the distance. Oh, looks like I've got some more work further on the other side. Let me, so as not to confuse, I'll cover that up for now. So we're just working with the distance. Okay. So again, the formula goes x2 minus x1, x2 minus x1. Be careful with your subtracting a negative. Quantity squared plus y2 minus y1 quantity squared, big square root around all that. That'll tell us the distance between. So working with those numbers, well, 5 minus -1 is 6. So we'll have 6 squared. That's -7. We'll square that. Be sure to keep those parentheses. That's going to give us 36 plus 49. The square root of 85 is the distance between those points. Okay, so it involves a square root. If we could reduce that square root, it'd be a good idea to. We would. 85, there's no perfect square that's going to divide into that. We cannot reduce this number. I like it just like that, square root 85. Okay, let's find the midpoint of the 2 points. Again, we want x1, y1, x2, y2. How do we do it? Take the average x value. So I'll just go x1 plus x2, divide that by 2. The average y value, 3 plus -4, divided by 2. Sorry if that's a bit small on the screen. And when we're done, well, we'll have 4 divided by 2 is 2. This would be -1 over 2, so that's -1/2. That is the midpoint of the 2 points. If we were in class, I would bring up Desmos on the screen to graph. I don't know if you guys, I forget if we've talked about Desmos in class. If we ever did that while we were still on campus, we might have not. I do it in almost all my classes, so I forget if we did it in our class. Go check this out, desmos.com. It's a free online graphing calculator. Looks really, really crisp and nice. You can plot these ordered pairs. So you can just put parentheses, -1, 3, parentheses, and it will plot that. And you can plot this one, and you can kind of look at those points and see the distance between and that sort of thing. That'll come in handy in later problems as well when we start looking at circles. Okay, that's all for this video. We're going to get to the equation for the circle next. See you in part 2.